Find the nth term of 0, 2, 5, 9, 14, etc. So when we're looking at this, we can see we're adding 2, we're adding 3, we're adding 4. That is not arithmetic. There's no multiplication factor that we can do. It's not geometric, so it is neither. So let's set up a chart. We'll go 1, 2, 3, 4, 5. I'm going to show how to do this two different ways. We already said that this was 2, 3, 4, 5. This is 1, 1, 1. So we know we're going to be looking for multiplication on this. When I'm looking for multiplication and I see that this is 0, if it is strict multiplication, then it's going to be 0 times something. Whereas before we would say, let's write it in terms of our case number. That's one of the things we tried first. If I see that there's a 0, I would like to try and see if a 0 would work in that spot. So if I put 0, 1, 2, 3, 4, let's see what happens. 0 times, it could be anything. Let's just leave that blank for now. 1 times 2 would give us 2. 2 times 5 over 2. 3 times 3. 4 times 14 over 4. And 14 over 4 reduces to 7 over 2. And now we look at that and say, well, what would this spot be in order to fit that same pattern? We could wait for a second if you don't see it right away. Is this good, bad, or ugly? We know this first column is good. Now let's look at the second one. We have 2, 5 over 2, 3, 7 over 2. We have every other one is a fraction over 2, so let's write them all over 2. We can just write down the ones we have first, and then we're going to put this over 2, this one over 2, and the 3 over 2. So 3 equals what over 2? It would be 6. Does that fit for this pattern? 5, 6, 7. This should be a 4. What is 4 over 2? 2. That looks good. And then this would have to be 3. Now we could say, let's look at the nth term. What is the formula for this? When we're looking at the formula for 0, 1, 2, 3, we ignore everything else. And we see that's an arithmetic sequence or a linear sequence. So this would be, it has a common difference of 1, so it's going to be n. What do you have to do to 1 to get 0? We would subtract 1. Or we could say, what's that term that came before it, the 0th term? That would also be negative 1. Now we're going to look at the tops alone, just 3, 4, 5, 6, 7. So if we were looking at just those numbers, what would that be? This also has a common difference of 1, so we know it's going to be 1n. What do I have to do to 1 to get 3? I have to add 2, or I could say, what was that term that came before it? That would also be 2. And then it's all over 2. So we have it. There's done. Let's take a look at another way to do the same problem. 1, 2, 3, 4, 5. 0, 2, 5, 9, 14. Now, when I'm looking at this, I looked at my differences here, and if I see these numbers here, 2, 3, 4, 5, that should remind me of a sequence we've already done. What was that sequence? That sequence was 1, 3, 6, 10, 15. How is the sequence I'm looking at related to this one? It is just one less in every single situation, every single case. Now we've already done the 1, 3, 6, 10, 15. So we know that one is n times n plus 1 over 2. So it's that minus 1. And that's all you would have to do.